Okay, in a moment we're going to talk about pointers, which are variables that can store and manipulate addresses. But before we do that, I just want to make a few more comments about addresses themselves. So we'll use an example with the same array, and let's say we wanted to go ahead and print out the address of the first element in the array. So that would be and array at index 0. Go ahead and compile that. I get that address. Okay. Now watch this. If I say printf, right after that, printf that some address, and I just say array, oops, I misspelled printf. That would help if I spelled that correctly. Okay, look, I get the same thing. So actually, I mean, this is strange. We usually don't just say an array by itself, right? We usually have its index. But what this is saying is, if I just specify the array, that's actually really an address. This is an address of the first element of the array. Okay? So that's kind of shorthand for this. Okay, so it always points to the very first element in the array. Okay, so that's the first thing I wanted to say. The second thing I wanted to say was, let's look at what happens when we pass along a variable to a function or a method. And let's look at what happens to its address. So let me make a method called passMeIt. And all it's going to do is print out some stuff. It'll print out the address. So, and that's all. Oops, %x. Okay. And what I'll do, let me go back to, let me go back to just a regular old int. Let's not worry about the array for a second. So let me say int x equals 4. Okay, and before I do that, I'm going to print out its address here. So we'll say original address is this. And I'll go ahead and I'll pass that x on to this function, to this method. Okay, so let's see what that does. So this is very interesting. The address of the version that is in this method here is actually different from the address in the main. So what's actually happened is when you pass a primitive type from one method to another as a parameter, it makes a copy of that. So these are not in the same location in memory. Okay? So when we pass primitive types, they're copied. Okay, now by contrast, let's say I do it on the array instead. And let me just go ahead and print out the address of maybe, let's say, element at index 2 in the array. Okay, so let me change this to be an array instead. I'll just call it x up here. Doesn't matter what I name it up here. Okay, so let's see what it's doing here. But here they're the same. Okay. So it turns out for arrays, it passes them, instead of by copying them, it passes them by reference. It does not make a copy. It actually just passes on a pointer to the array. So it just passes on the address here. All right, so warming up with that, we will talk about pointers next.